Welcome everyone to this session on input supply and integrity. How's that? That's the correct one. Welcome all to this session on agricultural input supply and integrity. We're going to wait just a couple of minutes for people to come in. So please pull up a chair, get comfortable. We're going to start at about 3 minutes after the hour. And the format is going to be that we're going to have 4 presentations, each of them 15 minutes long, and then we'll have some time at the end for Q&A. As you get settled, please note that you're not going to be able to access the chat, but if you have questions that come up before, during, or after the presentations, put them in the Q&A. I will be moderating, and if there are urgent clarifying questions, I'll interrupt the speakers, but otherwise we'll kind of gather and collect questions, and I'll put those to participants at the end in the discussion. So please do be aware that the session is being recorded. So if we call on you and unmute your microphone, you will be recorded for posterity, and your voice will be heard on the video. But thank you so much for being a part of this. And give us just another minute or so before we kick this off. Nils, do you want to go ahead and put some slides up? I think we'll kick off in just a second here.
Can you see the screen?
We can, and if you go full screen, we'll see it even better.
Perfect. Does this work? Awesome.
Well, why don't we go ahead and get started? Nils, you've got 15 minutes.
Okay, awesome. Thank you. Yeah. First of all, thanks to the organizers for giving us the opportunity to present our work here today. This is joint work with Tim and Doug, who are also in the call, as you've seen. And the core topic of our paper is the consequences of seed misidentification for the allocation of agricultural inputs. So first of all, a little bit of context. In most kind of studies investigating agricultural technology adoption or looking at improved seeds, self-reported adoption status is used to kind of elicit whether a farmer uses genetically improved seeds. So they go into the field and they ask the farmers whether they grow improved seeds or not, and that's kind of the measure. However, these improved seeds cannot be visibly distinguished from unimproved variety. So there is some sort of potential for misclassification. And recent studies in kind of agricultural economics and agricultural sciences have compared DNA measurement with survey response for the same farmers, and they do find a significant mismatch between the reported and the actual seed quality. So that's kind of the core facts that are motivating our paper. The aim now of this paper is to first investigate which farmers misidentify the seed type they're using. Second, what are the consequences of seed misidentification for the allocation of complementary inputs? And third, what are some sort of broader consequences of such misidentification for use of fertilizer in the overall economy? So let's firstly introduce our data set. So we're using the Ethiopian Social Survey, more specifically the 4th wave of the Ethiopian Social Survey. And this is the first nationally and regionally representative household survey that incorporates DNA fingerprinting data from maize, barley, and sorghum. It was collected by the CGIRA. And it's kind of, it's really a kind of a new approach to measure DNA adoption status on such a large scale. In our analysis, we focus primarily on maize. The reason for that is mostly just because their sample sizes are large enough to do some sort of significant econometric analysis. 2 things to point out. First of all, the genetic fingerprinting is kind of a trial. So it's only conducted on a subsample of the total survey population that focuses on specific regions. And also, this kind of trial nature leads to us having a high dimensional data set, which means we have very few observations, but we have many potential control variables simply due to the extensiveness of the Ethiopian Social Survey. Before kind of diving into descriptives, I think it's good to clarify terms, because this will be very important going forward. So we kind of categorize our pool of farmers into 4 different categories. And we do that according to the DNA type and the survey response. So what does the DNA measurement actually say what they're growing, and what do they report to be growing? And so if you look at the true positive and the true negative categories, those are farmers that correctly identify the seeds they're growing. So the true positives believe that they're growing improved seeds, and they actually grow improved seeds, and the true negatives believe they don't grow improved seeds, and they actually don't grow improved seeds. The kind of 2 categories that we are primarily interested in are the false positives and false negatives, because those are the farmers that actually do misclassify. So for example, the false positives, they think they're growing improved seeds, but in fact, they grow non-improved seeds. And the false negatives, they think they grow non-improved seeds, but in fact, they grow improved seeds. And I think a kind of good shorthand to kind of keep this in mind is that true false always refers to the genetic type, whether it's correct or not, and the positive negative refers to the survey response. So when we dive into kind of descriptors a little bit and look at the distribution of those 4 groups across our sample, the first thing we find is that all of these 4 groups is essentially represented in our sample, and that quite a significant chunk of our sample misidentifies. So we have around 60% of farmers that fall into the false positive and false negative category. And another interesting thing to point out is that if we look at if we compare the survey response to the DNA fingerprinting, we find that if we would just look at the survey response, we would find that 34% of the farmers use improved seeds, when in fact, if you look at the DNA type, 66%, or depending on the kind of purity threshold, around 60% use improved seeds. So there's some sort of underestimation of the utilization of improved seeds going on if we just look at the survey response. The question now is, how does this affect agricultural inputs? And I first want to introduce some sort of short theoretical model that we derived to kind of evaluate how we would expect an optimizing farmer to choose agricultural inputs, such as fertilizers, dependent on their seed type. So we would expect the optimizing farmer to choose these inputs in line with the underlying genetic type of their seeds and allocate more inputs to improved seeds than to unimproved seeds. So just to keep it short, the improved seeds, we would expect the improved seeds to influence the kind of productivity measure or the solar residual, which then increases the marginal productivity of labor and capital inputs, which leads to a higher allocation of inputs such as fertilizer. The next slide is putting this a little bit into the context, kind of showing this graphically. So we kind of here model the optimal inputs decision under certainty on the left-hand side and under uncertainty on the right-hand side. So if we first look at the left-hand side, we see on the x-axis we have the fertilizer intensity, and on the y-axis we have the revenue from yields. We have a cost, a kind of linear cost that describes the kind of higher fertilizer intensity being associated with a higher cost of fertilizer. And then we have 2 revenue curves depending on whether farmers use improved seeds or non-improved seeds. And so based on that, we kind of see 2 optima emerge. First of all, for farmers using non-improved seeds at T star, and for farmers using improved seeds at Y star. And if we kind of look at misidentification in this world, or in a world of certainty, the kind of misallocation associated with misidentification would just be the difference between I star and T star. So farmers who in fact grow traditional seeds, so should allocate fertilizer according to T star, but believe they grow improved seeds, so they do allocate fertilizer according to I star. The difference between the 2 is the overallocation. However, what we kind of think to observe in the empirical data is more the right-hand side, which is the world of uncertainty. Here, farmers aren't 100% sure whether they have improved seeds or not. So even a farmer who reports to have improved seeds might think that there is a likelihood that these seeds are in fact traditional. And what we would expect them to do as a consequence of that is that they would allocate less fertilizer than if they would be 100% certain. So in our data, what we will eventually observe is the difference between I prime and T prime. So we will observe a lower bound for the actual misallocation that's happening. So now let's kind of put this to the data, dive a little bit into the descriptives. And in a first step, we just split our sample by, first of all, by DNA type and by survey response. And we kind of construct these kernel density functions here. On the left-hand side, we see the sample split by DNA type. And the main thing we see here is that there's quite a lot of overlap between the two density functions. So the two groups don't seem to be that different in the way they allocate nitrogen fertilizer. But on the other hand, on the right-hand side, we see the opposite pattern emerge. There's very little overlap between traditional, between kind of the traditional survey curve and the improved survey curve, which would indicate that survey type is actually a pretty good predictor on how much nitrogen fertilizer farmers allocate. So what we also see from these graphs is that farmers who report to have improved survey type allocate more nitrogen fertilizers than those who report who are in the kind of traditional survey type. However, this could just be a result of these groups being different. Maybe there are some sort of variables such as education, such as gender, age, that kind of drive this relationship. So what we're looking at in the next step is just some sort of farmer characteristics by group. And what we do find is if we look at demographic characteristics, those four groups are not that different. However, if we look at kind of farming specific variables, those groups do seem to be different. So if you look at participation in extension programs, we see that true positives and false positives have a higher likelihood to participate in an extension program than true negatives and false negatives. And the same goes for seed source. So farmers in the true positives and false positives have a higher likelihood of having purchased their seeds than farmers in the true negatives and false negatives. And again, an important thing to point out here is that the means seem to be similar between true positives and false positives. So between the two groups that have the same belief type, and not between the two groups that have the same DNA type. So I think this just gets to show that maybe the underlying thing driving the allocation of fertilizer inputs is in fact belief type and not DNA type. In the next step, we're trying to kind of control for all of these confounding variables using a simple OLS, including belief status, including the DNA type, interaction effect, and kind of controls that we find in our sample, but also controls that kind of previous literature has identified as influencing selection into misidentification of seeds. So the results that we find here largely line up with our descriptives. So what we do find is that, first of all, for nitrogen and for phosphorus fertilizer, belief has a positive impact on fertilizer allocation. So believing that you grow improved seeds leads to a higher allocation of fertilizer. And this is also highly significant throughout our specification at the 0.01 level. So for example, for nitrogen fertilizer, if we include all of our control variables, we find that believing to grow improved seeds leads to an increase in the fertilizer allocation by around 48 kilograms per hectare for nitrogen and around 28 kilograms per hectare for phosphorus. If you look at the DNA type, we actually find a slight negative relationship for nitrogen. However, this kind of becomes less and less significant as we include more controls, and is only significant at the 10% level of full specification for nitrogen. Furthermore, if you look at phosphorus, it's actually not significant. So again, the overall message here is just that what seems to be driving allocation of fertilizer is the belief and not the DNA type. Okay, so this is obviously a fairly loose identification, and because we're including controls based on what we see in the data and what kind of past literature has identified. But in order to kind of make this a little bit more robust, we want to leverage on the high dimensional nature of the data set. And we're using a PDS lasso approach for this. So the key questions we're asking ourselves is which factors determine whether a farmer misidentifies their seeds, and do these factors influence input allocation? And again, previous literature has identified a bunch of characteristics. We find a bunch of characteristics, but there's no guarantee that this is an exhaustive list. So we're kind of using a machine learning algorithm to help us select controls. And just a really quick introduction into the PDS lasso approach. Essentially, a lasso is kind of a penalized regression. And essentially what it's doing is it tries to predict factors that influence our treatment variables, so that influence the belief treatment and that influence the DNA treatment. And it tries to predict factors that influences our outcome variables, so the allocation of nitrogen fertilizer and of phosphorus fertilizer. And then it runs a linear regression that includes the union of those two variables as controls. Now, if you look at the results of the PDS lasso, it kind of broadly lines up with our OLS results. So if you look at nitrogen fertilizer, the belief effect remains highly statistically significant, but obviously it decreases in terms of magnitude. And if you look at the DNA effect for nitrogen, it disappears in the PDS Lasso specification. And the same kind of effect holds for phosphorus fertilizer. The economic magnitude decreases, however, the significance remains the same. So what are our broad results? We find a large share of farmers in our sample misidentified the seeds they planted. We find that farmers allocate fertilizers in accordance to their belief about the genetic type and not the actual genetic type. And we find that the misidentification of seeds leads to systematic over and under allocation of complementary inputs that is driven by these false beliefs.
2 minutes, Nils.
Perfect. So in the next step, I think what we're trying to look at is identify the broader economic significance of this. So what are the consequences of this actually for the macroeconomy? And we aim to quantify this by kind of using again, a machine learning approach to kind of generalize beyond our small sample size. So what we do is we use a random forest to predict the DNA type for the plots that were not covered by DNA fingerprinting. That kind of allows us to leverage a nationally representative sample. And again, here we kind of use, again, the high dimensional nature of the data set. We kind of achieve a prediction accuracy of 80%, which is pretty good. And then we scale the prediction results to the regional population of around 9.5 million using the population rates that are given in the ESS. So that we're doing kind of some sort of back of the envelope calculation to look at the total fertilizer misallocation or the total fertilizer over and under allocation in these regions. What we find is that predicted fertilizer allocation for maize in the selected regions is around 65 tons. And the important part is that around 32% of total predicted fertilizer allocation seems to be over allocated and 7% of total fertilizer allocation seems to be under allocated. So those are quite significant numbers. So this misallocation, this over and under allocation really does seem to matter for broader allocation of fertilizer in those regions. And what are kind of implications and next step? One core question is what is driving beliefs? Is it the seed distribution system? Is it some behavioral factors? I think Paola will have much more to say about this. And then also, what are implications for the overall economy? How does this affect yields? How does this maybe affect the agricultural productivity cap? Are there any dynamic effects of farmers misidentifying seeds in period X and then kind of adapting the input decisions in the next period? Yeah, so I think those are all open questions that are kind of that we want to dive into, or that it would be interesting to look at. Yeah, thank you very much.
Fantastic. Thank you very much, Nils, and spot on time. Well managed. So we'll save questions to the end. And I think many questions that people have may get answered because Paola is going to be giving a talk which picks up in many ways where this leaves off. And so Paola, I'm going to turn things over to you. Nils, maybe you can stop sharing. And Paola, it's yours for 15 minutes.
Thank you. Let me just start sharing my screen. Is it okay? Can you see?
It looks good.
Fantastic. Thanks. So good morning, everyone, and thank you for joining. So the paper I'm presenting today tries to say something about the role of misperception in improved seed varieties, very much linked to basically the broad setting that Nils has presented. And indeed, I'm going to free ride on much of what he has already done to avoid replication. And so the paper investigates the role of misperception in improved seed varieties on production decisions. And so to start with a very broad motivation, we know that low adoption of agricultural technology is believed to be one of the crucial reasons why sub-Saharan Africa has failed to experience large productivity increases in agriculture in the last 60 years. And recent assessment actually claim that while fertilizers use remains low on average, improved maize variety are actually available in the markets. However, these two inputs are rarely used together on plots, despite the widespread evidence of agroeconomic synergies. And so many potential explanations for this have been put forward by the literature, thousands, which I'm not gonna talk about here for the sake of time. But one potential explanation that we try to investigate here is that maybe farmers are not making the correct production decision because they actually don't know they're growing an improved variety. And indeed, there is growing evidence that farmers' misperception on improved variety happens in different countries for different crops. And so if we take the case of Ethiopia, again, we see that farmers, if we ask farmers, they will report that they grow an improved variety in 45.4% of the plots. While if we actually use an objective measure, which is the DNA fingerprinting, we will obtain that varieties are actually adopted, improved varieties are adopted on 60% of the plots. So the question we try to answer here is whether misperception actually affects, is what affects actually production decisions and thus yields and profits. To do so, I'm going to be focusing on, since this complementarity in input use are exhibited especially in improved varieties, I'm going to be focusing on those farmers that actually cultivate an improved variety according to the DNA fingerprinting measure. And what I'm going to be looking at is farmers that have correct beliefs about it and farmers that have wrong beliefs about it. So it's basically the box that I'm highlighting here on this table. And so what this paper does is actually estimates the effect of correct identification of improved made varieties in Ethiopia on these different outcomes. And the thing that we want to stress is that basically we provide causal identification using the rollout of a government program that increased transparency in the seed sector, which is the direct seed marketing, which I'm going to be exploiting some of this variation basically through an IB approach. Moreover, we try to address sample limitation using machine learning techniques, and we basically predict the objective measure of the maize variety use using self-reported data, and we replicate the analysis, which allows us to replicate the analysis to the nationally representative sample. And so the contribution of this work are that we provide causal evidence that farmers who correctly classify improved variety actually exhibit a behavioral adjustment, and this allows us to quantify the cost of having incorrect beliefs about the variety you're growing, whether improved or not improved, which kind of suggests a potential explanation for observing resource misallocation, meaning that it's farmer optimizing a wrong production function rather than failing in their optimization process. And this is also, as I will try to convince you, there is some evidence, suggestive evidence of dynamic nature of farmers learning, as our ID strategy is basically informed by the number of years of exposure to a program that increased transparency in the seed sector, meaning it's a process that goes along many years. And so we also provide an interpolation model to scale objective measured data, and we can try to show that the implication of measurement error can go actually beyond potentially statistical inference only. And so the data, I'm going to not spend so much time on this, it's basically the same that was presented before, ESS4, that was collected actually, just not to piss off the LSMS teams that it might be connected, by the LSMS team and also the CGIR, so the partnership. And so the problem with this data, the limitation of this data is that, again, it was collected on a subsample, so you will see that the number of observations it's quite low. And then I'm going to be using administrative data on the rollout of the direct seed marketing program, and I'll control for other programs that might be compounding our identification strategy and make suitability years as well. And so this is to start off introducing the instrument. So the seed system in Ethiopia before 2011 was highly centralized, meaning that the seed supply chain unfolds from the Ministry of Agriculture through a number of actually offices of the government to the development agencies. And it's particularly worth noticing that basically seed suppliers, seed producers, seed enterprises, as we want to call it, didn't have any direct contact with farmers. But with the direct seed marketing, basically the government allows seed enterprises to actually market their seeds directly to farmers. And so the competition between these different suppliers actually calls for transparency in the characteristics of the varieties sold in order to gain market share. And so I'm going to be using the length of exposure to this DSM program as a proxy for learning about the variety available on the market and the which are the trustworthy actors involved in the supply chain. And so the DSM wasn't rolled out totally random. And so since I know from field work, basically farmers were explaining that exposure to better seeds is also a function of distance to the varietal town, I'm going to be using both variation and my instrumental variable, which is going to be the number of years of exposure to this program and how proximate households are to varietal towns. And I'll control for land suitability for my cultivation. And so the empirical strategy, so my first stage, as I'm using an IV, so the first stage is going to be that I'm going to predict the correct identification with this instrumental variable, plus a number of controls, which is always like exposure to the DSM program, presence of other governments program, suitability to maize, and their interaction terms and their interaction between these things. And so our final goal is actually to see how this correct identification affects inputs allocation, agricultural practices, yields, and profits, and so on. And so let me move directly to the results. So our first stage results shows that our instrumental variable is statistically significant and big in size. The F statistics suggest that we shouldn't be too much concerned about the weak instrumental variable problems. And then the coefficient is negative. And so the reason why we kind of expected it was going to be negative is the fact that the DSM program is going to be more important, it's going to have an effect, a stronger effect on correct identification, the less proximate you actually are toward the towns. So the program actually acts as a transparency measure, as a transparency channel, let's say, more for households that are in remote rural areas. And this is because seed supplier in this case actually makes the effort to do the extra mile in distributions, and so it kind of cuts off informal seed supply, informal traders. And so moving on to input use, we see a positive strong effects on urea and NPS to fertilizers. And so what this kind of suggests is that while urea is applied usually after germination, NPS is usually applied before germination. And so having an effect on both kind of suggests that farmers who correctly identify the variety used are actually making investments even before the germination. So even before they could actually grasp a signal that the variety is improved, meaning that they already knew they was improved. Also, the seedling rate, it's kind of comforting about the, let's say, the quality of the seed, in the sense that what farmers were telling me that usually to increase the probability of germination, you tend to spread more seeds, you tend to increase the seedling rate. Well, in this case, actually, we see a huge decrease in seedling rate for those who correctly classify. So they're quite confident about I think they're quite confident about the germination rate of this variety. Higher labor increases also, which is consistent with the fact that they're growing in high yield variety, and that they're using more fertilizers. So it's kind of going all in the same direction. Next, we might wonder if this boils down to having higher yields, if you are correct identifying. And yes, it seems to be a huge effect on yields, which is statistically significant. It's a 140% increase, actually. And if we worry about profitability, so we cannot detect, the coefficient is not statistically significant, probably due to the fact that maize profits, it's a very noisy measure. However, it's positive and big in magnitude. And this basically accounts for around $60 of increased profits, which if you compare to the control mean, it's quite big. And so the limitation so far is that, again, the DNA fingerprinting measure was collected on a subsample of the nationally representative sample. And so what we do here is we use machine learning to extend the analysis to the naturally representative sample. We use 120 covariates and we predict the DNA fingerprinting measure whenever it's not available. And so the model, it's basically an ensemble method of the usual suspects that are used for binary for classification problems. We train the sample of 491 observation, and we predict on 1,460 observation, which is basically all the farmers that grow maize variety. And we gain an accuracy of 85%.
And 3 minutes, Paola.
Fantastic. And so what I'm going to be showing you now is that we replicate the same analysis that I've shown you so far on different samples. I mean, I'm going to start enlarging my sample to understand how actually these predictions are doing and to understand what are the mechanisms behind it that could go on. And so again, I'm repeating here the first stage. And so the first column is basically I'm using the predictions that I have obtained with the machine learning, but on the original small sample that I was using for the main analysis. And as we move to the right, I keep adding households to the sample, plots to the sample, meaning the same EAs, but where there was not DNA fingerprinting measure, the same regions, but where there was not DNA fingerprinting measured up to the full sample. And so the thing here is that our instrumental variable goes in the same direction, but as we can see, it starts losing significance, starts becoming less powerful, let's say, and when I go to the full sample or same region, and this is probably due to the fact that I'm adding places, areas where maize is no longer so much relevant, and also the DSM program didn't roll out. So I'm adding, so that's why the instrumental variable seems to be less strong. And so if I replicate the analysis again, I'm reporting just a few coefficients, a few variables here, but you can see the full variables in the paper. And so what we see is that basically, very briefly, as I enlarge the sample, the effects are still there, are consistent, are robust, except for the seedling rate, which loses significance and changes in time. I'm still wondering why. I mean, I still don't have a clear explanation on this, but I'm digging more into it. And so to conclude, so farmers' correct identification of improved varieties leads to actually large increases in fertilizer use, hard labor. We have evidence that farmers are not actually crowding, that farmers are crowding in resources rather than reallocating these resources from other plots under other cultivations. And this is shown in the paper, I couldn't put it also here. We find no impact on ag practices. All of those practices, basically the CGIAR is spreading and inventing. We find large increases in yields and large increases in profits, although not statistically significant. And so the implication is that basically misperception in which agricultural technology you use has testable consequences for farmers' production decisions. And this is particularly important in light of climate change adaptation as climate-resistant traits. Given that basically new varieties are developed with climate-resistant traits, which require efficiency in resource use and potentially adaptable to climate-smart practices. However, if you cannot detect those traits and you're not aware, farmers are very unlikely to probably see this behavioral adjustment towards that direction. And thank you.
Thank you very much, Paola. Really nice presentation, well done. Please, I want to encourage those in the audience to submit questions in the Q&A. We'll get to questions at the end. And in the meantime, I want to turn things over to Chris Magomba for the next presentation. So Chris, go ahead and share screen when you're able to. And we'll hope that you haven't frozen here.
Yes, thank you so much.
Okay, great. All yours.
Let me share my screen. Can you see it? Can you see the screen?
Yes, we can see it now.
Okay, thank you so much, and thank you all for being here. And it's really nice to present our work that we have been doing here in Tanzania, in Morogoro. And today I'll be talking about the experiment that we are doing in Tanzania among buyers and sellers of fertilizer. And of this is to see whether we could, but also gaining a better understanding of how farmers form their beliefs about fertilizer. Do they, from which source? Hence the title, Correcting False Beliefs. So my presentation today will be based on the buyer side because, as I've said, survey to both sellers and buyers. So today I'll be talking about farmers. And this work is a joint work between myself from Sokoine University of Agriculture and Anemi Martens from University of Sussex, which I believe she is a participant here together with us, and Hope Mickelson from the University of Illinois. So we had the questions, and we were motivated by the fact that there is widespread belief in sub-Saharan Africa that fertilizer is bad quality, and yet there's some evidence which show that fertilizer is of reliably good quality. So we have been asking ourselves, can we change this incorrect belief? And if at all we manage to change this belief, can we change the demand of fertilizer? So basically, this is what we were being asked ourselves. And as I've said, the big motives of fertilizer, especially in sub-Saharan Africa, as we can see from the FAO, at only 18%, 18 kilograms is being used in most of the sub-Saharan African countries. But in the fertilizer consumption is about, on average, 9 kilograms per hectare. And this leads to low yields. And of course, we have been also getting information and data that there is also low use of improved seeds. So technically, if we talk about inputs, there is low use of inputs. And from our work, very first order assessment, it suggested that mineral fertilizer is profitable on average, will be profitable to farmers. So this is another question, very interesting. What explains low fertilizer use among smallholder farmers? And we have been, there's a lot of news, especially if you look, this is an example of the news that have been in the country. And the regulator, which is Tanzania Fertilizer Regulatory Authority, reported that there are a lot of fake fertilizer in the markets. So as a reason for farmers to maybe apply low fertilizer, or that can explain low fertilizer. Though I could say some of these news in the newspapers, but they are not. So it's only in the news. So our work will be contributing in some ways. As I've said at the beginning, that we had surveyed and do experiments to some small farmers in Tanzania. And we know, from the data, from the experiment, we get the evidence that fertilizer is of bad quality. And after that, we randomly sampling about 250 sellers of fertilizer and do a lab tests for more than 450 samples of fertilizer to show that fertilizer is good quality. So in this study, and today, what I'm going to share is that we use the randomized control trial to show that information in some villages nearby markets can help to change beliefs about urea quality. And we find that belief change maps into behavior. And if so, and the effect of changes driven the changes at the extensive margin. And if this changes, then there might be some new fertilizer users in the country. So actually, our good quality results is consistent with majority of research, as you can see here in my slide, especially if you look at the survey, the experiment that we did in 2015, 2016, we found that in Tanzania, is only 0.67% of the sample were out, and this we are talking about very interesting and surprising results as reported by Bohr et al. In 2017. They found that in Uganda, there is a considerable nutrient deviation, whereby on average about 30% of advertised content, nitrogen content, the results that we got from the literature. So persist. From the results, it is suggested that there is an equilibrium beliefs diverge from the truth. And if there is that equilibrium, we are asking some questions. Why can such an equilibrium persist in a competitive market? Then these are some of the reasons that maybe it is difficult to quality given the randomness, the stochasticity nature, and there could be some complementary underinvestment. And also, we know some farmers have some errors in application, the amount and the method and even timing of application. So, and according to the research that we did in Tanzania, 2019, Haru et al., it is maybe farmers, they are not purchasing and applying the right type of fertilizer. So these are some of the issues that might trigger the incorrect beliefs in the market. So let us come to our study site. As I said at the beginning, we did a study in Morogoro, Tanzania, and if you can see at your right-hand side, these are some of the, these indicate the village location that we identified in our cells in 2016. So we have this number of 8 villages in total. And these were categorized as treatment and control villages, whereby I'll talk about the intervention in the next slide here. So in the treatment villages, what type of intervention that we did is that we, after surveying, asking the farmers some questions using, then we gather everyone's treatment villages and type of information that we gave in this, in the right-hand side here. This is in Kiswahili so that they can understand, but literally in English, it is read that important information. The urea fertilizer that was tested in 2016 was found to have a good quality. So we tried to give this, we gave this information to farmers. And then after that, we left the farmers. Then I will tell you about the end line after we did the end line. So, sorry. You can see that a farmer baseline characteristics. When we did a baseline in terms of fertilizer use at the baseline, we divide categories. The first category is about 40% of the farmers who at the baseline had never used mineral fertilizer. And then we have another about 20% who have used fertilizer, but these ones, they did not use fertilizer in the prior season to our baseline survey. And then we have another 40%, only 40% at the baseline who used it. It implied that we look at the impact of the treatments. We have to distinguish between the internal and the external margin effects between these categories. So let us talk about the results. Some of the results, as I've said, I'll be talking about the farmer end. We wanted to simply describe the quality concern of farmers in the region. So every village that we visited, we asked a number of questions, and one of them is this one in order to elicit the beliefs. So we asked farmers to imagine a scenario that if 10 farmers like you in this week, how many would be of bad quality and how many will be of good quality? Of course, we also describe or defined what do we mean by bad quality and what do we mean by good quality. So this type of formulation, as opposed to probabilistic statement, did well in pre-testing, as the farmers commonly purchase 1 kilogram of fertilizer, and they could be possible to judge whether either the fertilizer quality or wide variety of beliefs. And about 20% of farmers think that there are issues. There are some issues. There are no issues, as you can see here. Out of 10 bags, 20% farmers believe that there are no issues with quality of fertilizer. So this implies that we would expect our intervention to work most on the right hand. These, especially, of course, the results of others are well distributed, and this is normally distributed, as you can see. So we thought our intervention more for these who are believing that there are some issues in fertilizer. So at the baseline, we found that only 16% of the variation in concern is at the village level, meaning that even within the village, there are some people, and you can see here from the data, having ever purchased the fertilizer before has a strong negative relationship with the first magnitude of the quality of concern and whether the farmer reports any concern at all. So there are a few reasons which village level understanding. One might be this use of fertilizer quality might simply not be important enough for some of the farmers. They don't care about quality, and maybe within the bigger picture of everything that is going in their lives, so they don't care, they don't mind. Another one is the well-established that advice taking and the beliefs formation is not an easy process. So farmers and don't care about anything that they believe. And people tend to be overly confident of their own prior opinion, even in the face of new contradicting advice. So let me talk about some of about beliefs. We found that farmers who have not purchased the fertilizer before are more likely to be concerned about quality. And also, they have more serious concern about quality. Going further, the information that we collected at the baseline, at the end line in person, documents the importance and the strength of our village information treatment. As you can see here, everyone in the treatment villages from whom we interviewed at the end line in person has attended our information meeting. As I said at the beginning, we had a meeting and they reported that the information that we gave was both. Also, we noted that information has some effects on belief. Here, as you can see in the slide, we noted that and which represent about an effect of about 17% of the sample. So we believe that, we see from the data that information has really effects on fertilizer, on belief. And also information affects farmers' purchasing. As we can see, as I said at the beginning, there are some behaviors due to our intervention that has been changed. We see that here, we presented the effect on a series of dependent variables. And of course, some of you might be able to recognize these fertilizer. We have urea, DAP, and Ken. So here, some of you, these are some of the names of inorganic fertilizers which are used in Tanzania. And I'm glad that even Paola presented some. You can recall that in our treatment, it was all about urea, and because this is what we had the results. So the dependent variable here we can see is whether or not the farmer purchased this fertilizer that season. So this is actually the extensive margin, the decision whether or not to use fertilizer. So it is on this margin that we note an increase, an effect of about 12% points for urea. You can see here in urea. And from this one, this is an average of around 40% among the analysis. But as you can see, we have an effect in other fertilizer for DAP and for CAN. In this slide, we present the effect of fertilizer per acre. And we see that there is an effect on quantity of fertilizer applied per acre. And it is estimated that the effect is around 6 kilograms per acre, which corresponds to an effect of 54%. And actually, this is indeed 6 corresponds to 54% of the sample. So we see that there is an effect on information to quantity applied, fertilizer applied at a particular. Before I conclude, we also looked at other effects with our small sample of 30 villages at the end line. Here, in order to elicit some effects on farmers' behavior. As you can see here, we should note that agrochemicals are not typically used on maize because our sample was maize farmers. So you can see here, agrochemical is not used on maize, but commonly used on other crops. So we saw that there was an increase in the use of hybrid maize seeds, no increase in the use of agrochemical on maize, as I've said, and no corresponding increase in maize yields and no increase in beliefs about maize yields. Here, this might be because the increased fertilizer was not enough, or it was used on another crop. So, or there are some
I think we lost Doug as well. Oh, there we go.
Hi all, sorry, I think we lost connection there. Hopefully, hopefully Doug's back.
Hello?
Chris is back. Sorry, I also dropped off for a bit. Did Chris manage to finish?
So as I'm concluding, so
Okay, great, thanks. We all lost, thanks.
Okay,
Go ahead,
thank
Chris.
you so much. And you are welcome for comments and questions. Thank you so much for listening. And sorry for the cut of the internet.
I think we don't have Chris back yet. I don't know if we should carry on.
Maybe I should just jump in
Doug,
and
do you
give
want
my
to go ahead?
presentation.
I think
Yeah.
so. Thank you.
Why don't I do
Thanks.
that?
Bye. Bye.
Okay, hoping everyone can see my slides.
Perfect.
Excellent. Okay, so thanks everybody. I'm realizing now as the last presenter in this session that there were 3 very similar presentations and I'm the odd one out with a very different presentation, but that's okay. Hopefully, hopefully we can deal with a little variety in this session. So I'm here to talk about an impact evaluation I ran with a bunch of colleagues and collaborators, hence around 1 billion people in the author list. And so the motivation is to think about the broader literature around livelihood programs and specifically graduation programs. So I think we all know that these comprehensive graduation programs have shown terrific results in recent literature, specifically the 6-country study by Banerjee and co-authors. But there's this downside that they're very expensive and cost effectiveness is pretty questionable unless they have really long-term effects. There have been a few attempts to try and do lighter versions of them, and one by Banerjee again that just provided assets was not very successful. But I think that there's a lot of talk, especially with implementers, about trying to innovate on these processes to try to see if we can get the high effects, long-lasting effects of graduation programs without all the cost. So into that, we enter the Human Development Project, which is something that we at ID Insight developed along with 1 Acre Fund, where the idea is, what if we scan the literature to try and figure out a bunch of evidence-backed rural livelihood interventions, piloted and refined them to a local context, and then delivered them as a low-cost bundle to poor households. And really, in this intervention, costs were always at the top of our mind, trying to think about how can we design a high-impact, low-cost intervention that can be delivered at very low costs and could be incredibly scalable. And the idea is something that could be much more scalable than, for instance, 1 Acre Fund's core program, which relies on loans and therefore a certain income level of farmers. And so what we did is we spent roughly 6 months going through literature review, a comparative cost model, farmer consultations, and field trials to come up with this bundle intervention that basically what we did is we did a one-time distribution of a bunch of inputs across sectors to households that cost about $115 per household. And the bundle included maize inputs, so improved seeds and fertilizer, 10 hybrid chickens, solar lamps, tree seedlings, crop storage bags, bed nets, and a corn soy blend, which is nutrition for kids. And then we did a randomized trial to try and figure out, hey, does this work and is it cost effective, which was the main goal. So this pilot randomized trial took place in Singida, Tanzania, the second poorest region of Tanzania. 95% of households are growing crops as their primary source of income. It's mostly maize. And this area was chosen due to relatively high potential for improving maize production, but also it wasn't somewhere where 1 Acre Fund worked with their core program, which is more loan-based. What does this design look like? Well, it's a cluster RCT at the village level. We randomly selected villages from the complete list in Singida, Tanzania, included 192 villages for a total 1,920 households. We randomly picked one neighborhood per village to implement the program or / do our sampling in the control group. And one thing that's kind of innovative and cool about this study is that, like a normal RCT, we surveyed all the households at baseline, but then we did monthly follow-ups with 1/3 of the households each for 12 months. So we actually have monthly data, and then we can also aggregate some of this monthly data to get our full sample at different points in time. And the point of doing this was that there are all these different inputs that we were expecting to pay off at different points of time in the future. So we wanted to kind of understand what was paying off at certain times and get a little idea of the temporal distribution of impacts. Okay, now when you have a bunch of different inputs, when the intervention is multifaceted like this, it can be pretty difficult to figure out what is the right outcome variable to measure. And so we have lots of different outcome variables, but we have two primary outcomes. The first one is what we call direct income gains. And this is income from sources that are directly attributable to the interventions that we did. So this would be like the equivalent of, if you did an agricultural intervention, this is agricultural profits, like similar to some of these studies that we just showed. But because we're also giving them chickens and solar lamps, which are supposed to cause income gains, we kind of bunched these proximal outcomes together into one net indicator. We also looked at consumption, which is a further downstream outcome that might be more important if you might be worried that people are substituting away from other livelihood activities because of this bundle. Also looked at assets, utilization of the products, and some high-level health-related outcomes. Okay, so let's jump into some results. That's the most fun part. So what did we find? So remember, we dumped this bundle of stuff onto people, one time touch, a little bit of trading. Then what I'm going to show you now, this primary outcome, this directed income gains, is roughly 10 months later. What do things look like? Well, we see a couple things, and these are the three outcomes directly related to income. First of all, we saw a massive increase in maize profits, increasing by around $122, almost tripling maize profits. So that's pretty awesome. Kind of reflects this finding that we saw from Paola earlier, that if you give low-producing farmers good seeds and good fertilizer, there can be major impacts on yields. On the other hand, on the chickens, remember we gave away 10 of these improved Sasso chickens that are supposed to be able to, at very low cost, make money for farmers. We saw very little impacts of that, around $8. And then energy profits, this basically comes from reduced energy spending, reduced kerosene specifically. We see an increase of about $16. So by our main outcome, which is this direct income gain, we have pretty massive effects 10 months later that are well above the transfer amount of, well, the transfer amount was $115. Our total income increase 10 months later is $144. Sorry, one thing I forgot to mention is these maize profits, all of these outcomes are measured, they're aggregated over time. So we're checking chicken profits on households every 3 months, checking maize spending or maize revenue every 3 months, and then we aggregate it over time over the year to get these total income changes over the year. I think I misexplained that a second ago. Okay, so just click down into some of these things. So the maize income, where is that coming from? Well, you might say, all right, you gave these farmers a bunch of fertilizer and seeds. The increased profits is probably coming from just substituting expenses they used to have. We find that's actually not true. That we don't really see much substitution of the expenses. Control and treatment have around the same expenses. but we do see these massive income gains, and that's really coming from increased yields. So that's how the program was supposed to work. That's terrific. So now let's double click on chickens, which was supposed to be the other big income generating component of this bundle. And what we see is that income increased by about $29 over the course of this first year, which is okay, but a little bit disappointing. That's like in the ballpark of what these chickens cost. But the thing that we see that is pretty disappointing is that these treatment farmers actually spent a lot more money on the chickens than control farmers spent on their own chickens. And so that's a little bit to be expected. You know, you have 10 more chickens, you have some more expenses with them than you didn't have before. But also these chickens have been really touted by both the companies that sell them, as well as a lot of people in the international development community, as free money for farmers. You just get these chickens, they kind of peck around, you don't really need to feed them, and then the farmers get money. That turned out to really not be true. Farmers were spending a lot of money on chicken feed, for better or for worse. And that really eroded the profits. So in the end, we have pretty minimal profits from these chickens. And I think another important thing to know is after 1 year, farmers only had 3 chickens remaining, which is partially to be expected. I mean, people sell chickens, they eat them, that's the whole point. But we may have hoped that they would have survived and been a longer term income source. Okay, and the final income generating thing are these solar lamps. They're generating modest but statistically significant impact. This was roughly in line with our expectations, where solar lamps are helping people make a little bit of extra money from, like, some people have set charging businesses where they charge their neighbor for charging cell phones. They spend a little bit less money on energy from other sources. A lot of times that's lighting or paying other people to charge their phones, and they get some modest profits of around $16 after the first year. Moving to consumption, we see that after 1 year, households have roughly 10% or $10 higher consumption. And so that's good to know that people aren't just like substituting one source of income away from another. It looks like these income gains are actually translating into consumption. And we can actually map out the consumption over time because, like I said, we had these monthly surveys. And what we find is that, so in this region, the harvest is happening around June and July. So what we find is that in the early days, as you might expect, the chickens are young. The maize hasn't been harvested yet. There's basically no effects for the first 6 months. And then you start to get these really positive effects right around the maize harvest, which again corresponds with the other evidence we've seen that all impact is really happening through a great maize harvest. We didn't see changes in assets. It's not that surprising, I suppose, given the short time frame. We did see increases in some of the utilization of these other non-income generation projects. So an increase in people sleeping under bed nets, which is probably good, but we didn't actually see increased net usage for children under 5 who are most vulnerable to malaria. So sort of mixed results on bed nets. We see higher consumption of this corn soy blend, which is good. It's hard to know about downstream outcomes. And for the trees, we saw that most farmers planted these trees, and these are supposed to be long-term income generating tools. But after 1 year, only 9 trees per farmer had survived on average. So that's definitely below the hope and expectation of this intervention. We see a little bit of increase in minimum dietary diversity of children, but we do not see an increase in the proportion of children between 6 and 23 months consuming iron-rich foods. So just a little bit of a post-mortem on the bundle. What do we think worked? What do we think didn't work? Well, the maize worked great. The hybrid chickens were a failure. The solar lamps and PICS bags, which I didn't really talk about before, they were cheap interventions that that seem to give some modest returns. Some of the health parts of the bundle, it's a little bit, we saw increased utilization, but a little bit difficult to tell the downstream effects. And then the trees were also somewhat disappointing. We took a look, this program was all about cost effectiveness. So we tried to look at the cost effectiveness compared to a bunch of other livelihood and graduation programs, cost effectiveness estimates that were put together. We only have 1 year outcomes, so we try and compare to 1 year outcomes of other effects. And we find that we have roughly, like our return on investment is roughly 50%, which is not great after 1 year when we take the costs into account. And this is taking both the farmer level costs and all of the distribution and coordination costs. We get roughly about 50% returned. That's better than a lot of stuff we see out there, like cash transfers, livelihood development, graduation programs. There's this Suleiman et al. Paper looks at that, but it doesn't look quite as good as 1 Acre Fund's core program or Mozambique maize, this Carter paper on maize impact subsidies, that are sort of seem like the vanguard of things that have happened recently that have really good cost effectiveness. If you try and project out, if you make some assumptions of costs getting better at scale, you actually do get much better returns of above 1, of potentially 1.8 for maize or 1.3 for the whole bundle. Anyway, I know I only have a couple seconds left, so I'll conclude. So by the definition of our pre-analysis plan and what all the stakeholders agreed would be success, this program was a success. There were big gains in income and consumption that were well above what was spent per farmer. But I think when you dig down, it's hard to come away from this and say like, oh my gosh, this is something we should scale up. It was this bundle approach, but the gains were really all driven by the maize inputs. And which brings up some external validity concerns. I mean, we saw a couple of presentations earlier today that gave vastly different yield results from different input programs. And, we saw an incredible result here, but this is a region that has low initial maize productivity. We gave them inputs and there were terrific complementary rains. It's not so clear if we would have these great results in another year or in another area. And another open question are the long-term impacts. The cost effectiveness of this program is going to be way better if some of these impacts persist, but we didn't have any money to do longer-term surveys, so we don't know. Anyway, I'm 1 minute over, so I will stop. Thank you, everybody.
Thanks so much, Dan, and thanks to everyone. And my apologies. I think Bronwyn's as well. It looks as though Oxford University has worse internet than Sequoia and has worse internet in turn than anybody else. So we all dropped for a period of time. Having said that, we're back for now, at least. Love to open things up and see if there are any questions. So please, you can either type your questions in the Q&A and I'll pick them up there, or put a hand up. So panelists are also welcome to ask questions of each other.
I'm happy to start with a question that could maybe go to either, really to any of the previous candidates. I guess I was just trying to wrap my head around, it seems like, especially what Paola and Nils were doing, there's this major assumption that fertilizer and improved seeds are complementary inputs. And I believe that, don't get me wrong, but I'm also just wondering, like, what type of magnitudes are we talking about? And what is the risk? Even if you use improved seeds, are you going to get massive difference of returns in different years based on fertilizer? It almost seems like that based on n=3, where all three of you kind of have different, or those of you who have yield results seem to go in different ways. So I'm just wondering, like, how much of a slam dunk is it, and could we be causing any adverse effects through these information interventions?
Paola, I wonder if I can ask you to kick off on that.
Yeah, it's a great question. So the reason I'm not an agronomist, however, the reason why I actually do the analysis on the people who have farmers that are only have improved varieties by the objective measure is exactly this. And so in that part of the analysis, I'm basically comparing people that grow these improved varieties, but the only difference is how much actually fertilizers they use, right? At the end of the day, that was the only dimension that was really varying. And by using all of that amount of fertilizer, whether it's the perfectly recommended amount, I'm not sure. Probably I should dig more into this, but it does translate into a magnitude of yields that it's 140%. Now, whether we believe in the instrumental variable, I mean, always happy to debate on that. But I mean, it seems to go in this direction that actually, if you do not use those fertilizers, you don't experience this huge increases in yield. I'm not sure whether Doug, if you want to add something.
Let me ask Chris to come in next, and then I'll offer a thought.
Yeah. Hello, and sorry for being cut off with the internet. I hope now I'm clear. You can hear me.
Better than Oxford.
Yes. Yeah, so I also agree with what Paola has said. You know, the reason farmers, they don't get good yields after applying fertilizer and using improved seeds is because of some of the agronomic practices that they are not using. For example, here in Morogoro, around 2015, we had a study in about 50 villages, and we found we were testing soils, and we found that farmers, they don't know the quality of their soils. So they even don't know the right amount of fertilizer, the type of fertilizer to apply. So I think those are some of the issues that make farmers to get low yield, even though they are using fertilizer and using improved seeds. And also the errors, of course, even though they know that they need to apply maybe urea in 1 acre, and they have the right content, but maybe the timing also matters. So there are some issues that are attributing to this, and this, which is really we need to also to see. For example, other issues like bad weather, and of course, I've already said about errors in application. So this, I think, what I can contribute. And I know the study done by, I mean, I know Singida. I've been in Singida so many times, and it is really semi-arid area. And so maybe the reason for low yield is because of the weather, because that area is, of course, they get very low rain. So I think that can be one of the reasons done. Thank you.
Except the year that I did my study, and we were super lucky, hence the high yields.
I guess I would only add the observation, which is in some ways consistent with Paola's results, that yield doesn't imply profits. And certainly when yield that's driven by costly fertilizer inputs doesn't imply profitability. And because what we observe typically are market prices for these things, which don't correspond to the farm level shadow prices, it's possible to be driving yield effectively in a technical sense without actually making this profitable under farm conditions for farmers. You know, just a huge amount of heterogeneity, I think, in these shadow prices. Other questions? Opening it up again to our massive audience. Love to hear anything that people have.
I actually own an answer to Anemi, who wrote on the chat, but I was following the other presentation, so I kind of got lost. And so Anemi was asking, I'm not, Anemi, what do you want to ask your question directly if you're still online, or should I just read it? Yes, there she is.
1 second. Oh dear.
I think you're unmuted now.
Right. Can you hear me?
Yes.
Yes.
Yeah. No, I was, when you were presenting, and I think you mentioned at some point you had a slide about the input dealers and kind of how it worked. And I was almost trying to imagine a conversation between the input dealers and the farmers, kind of picking up their bag of seed and kind of talking about, presumably, a little bit about
You're on mute.
Yes, I changed to panelist apparently in the meantime. Yes. Yeah, so I was just wondering kind of what your thoughts were about the motivation of these input dealers are, of course, key, right? Because they probably don't have a motivation to sell seeds that they think are hybrid as non-hybrid, as presumably there's a price difference between the two types of seeds. And so what was striking from your cross-tabulations, just the basic descriptive statistics, is that they got it wrong in that way much more often than the other way around. So in the way that does not economically make sense from the point of view of the input dealers. So I was just kind of wondering whether you have any insights about this conversation that is happening between input dealers and farmers, and kind of how this conception comes about.
Yeah, no, it's an excellent question. And so the idea that I actually, that I got for myself is that basically, if we're not implying, I didn't really imply when I was talking about formal dealers that they're doing it, that they're actually using counterfeited seeds or whatever poor quality seeds actually with bad intention. They might as well be confused themselves about what they are really selling. And so the idea would be to actually improve kind of the seed sector, make it more transparent also for those dealers, which might be confused, and introducing even more confusion among farmers. And what the direct seed marketing was actually trying to do is actually get rid of this, in some sense, these informal dealers and allowing directly seed producers, which should be, in theory, less confused about it, or should be generating less confusion about what is the quality of the seed and whether they are improved or not improved.
My sense, just to clarify, is I think NME is probably asking about the other quadrant, the people who are using improved seeds when they don't actually realize it. And as you point out, NME, I think it would be unprofitable, seems like it would be unprofitable and undesirable for dealers to sell people seeds as traditional that are in fact improved. My sense of what's going on, but I'd be curious, Paola, to know whether you think the same thing, but is my sense is that what's happening is that these are farmers who probably didn't actually purchase seed and are using recycled seed or borrowed seed or seed they got through some other source. Because they didn't purchase it, they assume it's not improved, whereas in fact the DNA sampling shows a significant presence of genetic markers or genetic characteristics that would be typical of improved varieties. Is that your sense, Paola? And is that an answer to NME's question, I suppose?
Yeah, I think that it could also be that maybe farmers believe that after 1 year of recycling, they thought the variety lose every improved traits while we still capture it through the objective measure, because maybe you need 3 cycles of recycling of those seeds before they actually lose any improved variety trait. That's of course a possibility. Unfortunately, from the data, it's really hard to tell from the data we have now.
But that makes things more like your context, Chris, where farmers mistakenly believe that the inputs they're using are of poor quality, and in fact they're better than they expect. And so I think there's a whole set of interesting questions, as Dan says, that we really need to unpack here. Is how much are farmers too pessimistic about the quality of the inputs? In some cases they are, and in some cases it seems that they're overly optimistic. And gosh, Chris, I'd love your thoughts on seed, which is something you didn't talk about explicitly, but whether you think some of the same thing may be true with seed in your context.
Sorry, I just mentioned that generally, in sub-Saharan Africa and technically, I mean, specifically in Tanzania, the use of improved inputs is very low, including seeds. And remember our study, we surveyed the agro dealers and farmers. So agro dealers are those who are selling all types of agro inputs, including seeds, including fertilizer, etc. So that's why I mentioned at the beginning that the use of inputs, including improved seeds, is very low. Of course, fertilizer is also very low in Tanzania. Yeah.
Other questions? Tim has a sort of complicated question in the chat for you, Paola, but I might just let that one go offline because I'm not sure that's going to be quite a narrowly formulated one. We just have a couple of minutes left before things cut out. Anyone else with questions or comments? Dan, let me come back to you. You've got this really interesting intervention, at least the part of it that I heard, with multiple inputs and multiple lots of stuff going on. Do you see the integrity of the input supply chain being an issue in any of the cases that you're dealing with, or is that something you're able to control experimentally?
Well, I think that for the vision of this intervention, it's really centralized purchase of inputs dropped on people. So I think it was pretty well controlled. Like we bought, the implementers bought the improved seed and seed, chicken, and fertilizer straight from high-level dealers in bulk. And actually, when you're thinking of these big at-scale things, you're buying pretty high up the supply chain, and so it should really be okay. You know, that being said, like I said, one of the big questions about our study is we saw these great outcomes in year one. Would it persist until year two? If it's going to persist in year two, you need people reinvesting these profits in more inputs. And if in year one they get the pure inputs, and year two they got to go to the dealer and they don't know what they're getting, you know, you could mess things up quickly. So I certainly think, like, in the long term, it would be a worry, just like for everyone.
Good. We are just about out of time. Other questions? Just maybe I can just say in sort of closing things up, I think there's a lot of interesting work to be done here in trying to unpack what seem to be input markets where there's low quality, well, let's say there's variable quality, there's low confidence in the input quality. There's certainly low intensity of input use. I mean, shockingly low. The question is not, going back to the RCT literature on fertilizer in Kenya, the interesting question shouldn't be why so few farmers are using fertilizer in a binary sense, but why the optimal levels for farmers who do use fertilizer tend to be so very low. The profit maximizing levels are single-digit kgs per hectare. And so maybe understanding a little bit better what are profit maximizing levels, how to deal with quality issues, certainly a first order set of concerns, and great to see a bunch of research that's really taking this on. And data collection, and just to say, the ESSP survey that both Paola and Nils et al. Have used is the first study of its kind to do this nationally representative DNA fingerprinting. I think we're still lagging behind on other inputs. So a lot more information to be collected, a lot more to learn about input supply chain, input use, and farmer beliefs. So anyway, on that note, may I just thank all of the participants. I'd like to thank Dan for getting up at a very early hour of the morning, Chris for fighting through internet struggles at Sequoia. I'd like to apologize for the Oxford contingent disappearing from internet connectivity, and look forward to continuing these conversations. Not least, I should add, there's another agriculture session in the conference later today. So I hope to see many of you there and look forward to continuing these conversations more generally. So thanks to all.
Thanks, everyone.
Thank you. Thank you.
Thanks.
Thank you. Thank you.
Bye, everyone.
Bye.
Thanks, everyone.